Hi, I'm Adnan Akbar, MPhil in Physics and BS in Mathematics, and today I am here again with my YouTube channel named Visual Physics. And today our lecture is now lecture number 3, and we have to discuss the Coulomb's law problems part 2. Let me tell you, these problems are very important and concept based, and it is actually a training for you to solve the complex problem of Coulomb's law. And let's start without any delay. We have our first problem. We have a secure shape in which charges and length distribution is shown in the figure. Find the force at minus q charge at point D. Let's analyze the figure. Here the secure shape ABCD is given and four charges are oriented at its corners as shown in the figure. These charges are similar in magnitude and they are equidistant from each other along each length of secure, and three of these charges are of positive nature and one of them is of negative nature as shown in the figure. We have to calculate the net force at point D. For this purpose, we have to observe how many forces are acting at point D. In the figure, one force is from B to D, and second one is from A to D along the diagonal, and the third one is along the C to D as shown in the figure. Then the net force at the point charge D will be actually the sum of all these forces by using the superposition principle. F net is equal to FCD plus FBD plus FAD, where FCD and FBD are perpendicular forces. Then they will give some resultant. So FCD plus FBD is equal to FR. After putting this value in equation A, our equation will become F net is equal to Fr plus FAD. Equation 1 is showing to calculate the net force, we need to calculate the resultant force Fr and diagonal force FAD. From the figure, forces FBD is equal to FCD because along these lengths, for charges have the same magnitude and they are equidistant from each other. So the forces along these lengths will be equal to each other. So FCD is equal to FBD is equal to F. Then applying the law of cosine to calculate a resultant force, Fr is equal to square root of F square plus F square plus F dot 2F dot F cos of 90 degree, and you know cos 90 will result 0. So our equation will become Fr is equal to square root of F square plus F square, which will result F multiplied by square root of 2, where F is a Coulomb force between 2 point charges separated by a distance A. So our equation will become square root of 2 multiplied by K Q dot Q over A square, and our final resultant equation will become Fr is equal to square root of 2 multiplied by Kq square over A square. Now let us find the value of force along the diagonal AD, and for that we need to understand value of R is actually equal to the length of the diagonal, which is A square root of 2. In case of the diagonal charges, point charges at A and D are separated by a diagonal length which is A square root of 2. Then we have to apply the Coulomb's law between these 2 point charges at A and D. Our relation will become FAD is equal to KQ dot Q over A in square root of 2 whole square, which will result KQ square over 2A square. Now we have found the resultant force and force along the diagonal. Then let's replace these values in equation 1 to calculate the final net force. Our equation will become F net is equal to square root of 2 multiplied by KQ square over A square plus KQ square over 2A square. In this equation, you can see KQ square over A square is common. So by taking common it, our equation will become KQ square over A square into square root of 2 plus 1 by 2, which is the final relation for the net force at point D. Now let's move towards our next conceptual problem. Here, we have to find the net force F net at the charge on vertex C. Let's again analyze the diagram. Here, the given diagram is a triangle ABC, and three charges are oriented at its corners as shown in the triangle, and each charge has the same magnitude, same nature, and the distance between 2 point charges in this figure is A, which is similar in along three sides of triangle. So what we have to calculate? We have to calculate the net force at point C, vertex C. So we can see in the figure the force from B to C is FBC and force from A to C is FAC. And we know the sum of the angles in the triangle is 180, then the angle between two sides will be 60 degrees. So the angle between FBC and FAC will be 60 degree. And one thing more, the force between 2 point charges, for example, between B and C, and will be same as the force between A and C and between A and B. So let's calculate the force between 2 point charges. FCB is equal to KQ dot Q over A square is equal to KQ square over A square plus is equal to FCA, which is equal to F, which is showing that the forces between 2 point charges along each side of triangle are equal or similar. So now let's find the net force at point C. For this purpose, we have to apply the law of cosine. Our relation will become Fr is equal to square root of F square plus F square plus 2F dot F cos of 60 degree, and cos of 60 degree will results 1 by 2, and our relation will become Fr is equal to square root of F square plus F square plus 2F dot F by 2. Here 2 will cancel the 2, and our relation will become Fr is equal to square root of F square plus F square plus F square, and then our relation will become F multiplied by square root of 3. And the value of F from equation A, we know KQ square over A square. Then our relation for the resultant force will become Fr is equal to square root of 3 multiplied by KQ square over A square, which is the net force at vertex C. And now let's move towards our next conceptual problem. Net force on the charge lying at the center of square, rectangle, and triangle. Here we have to discuss whenever the charges are oriented at the corner of rectangle, triangle, or square, then what will be the net force at the charge at their center? We have to discuss it in two cases. First case, when all the charges at the corners will have same magnitude and same nature. So let's start. In our first case, we have a triangle and three charges are distributed at its corners, and they have same magnitude and same nature. So their net force at the central charge will be equal to 0, because the forces applied by these corner charges will be equal and opposite in direction. They will cancel their effect at the central charge. So net force at the central charge will be 0, and central charge will remain stationary. And let's move towards our next diagram. In this diagram, four charges are oriented at the corner, and fifth charge is at the center. Here again, these charges have the same magnitude and same nature. So the forces applied by these charges at the central charge will cancel their effect. So net force at the central charge will be 0, and charge will remain stationary. The second case that we have to discuss, it may be possible in some cases that the charges at the corners do not have the same magnitude, or they do not have the same nature. Then what will happen? Then in that case, at the central point charge, net force will not be equal to 0, and charge will not remain stationary. Let us discuss example problem related to this case. Find the force at plus Q charge in the diagram. Let us analyze a diagram. Here is a secure shaped diagram A, B, C, D, and four charges are oriented at its corners as shown in the diagram, and the distance between 2 point charges along each length is similar, which is A. Three of these charges have the same nature, which is positive, and one of these charges has negative nature as shown in the figure. What we have to calculate? We have to calculate the net force at the central charge in this case. One thing that I need to clear, the force applied by the charge at point B on the Q and the force applied by the charge from point D at point Q will have the same magnitude. So they will cancel their effect. As a result, net force will be equal to 0. Both similar and opposite forces are cancelling effect of each other. Now let us discuss the force due to 2 point charges at A and C. Here, two forces are acting at the central charge. One is a repulsive force from A to plus Q, and other is attractive force from Q to minus Q. Then these both forces have the same direction. As a result, they will give a double effect. Let us check. While forces along the diagonal A to plus Q and plus Q to C are add up to give double effect because they are in the same direction. So net force along the diagonal is equal to F net is equal to F plus F is equal to 2F. Now we have to calculate the force applied by a point charge at the central charge. Then we need to apply the Coulomb's law as this force is along the diagonal. So in the case of the diagonal, our distance r between 2 point charges will become r is equal to half of the diagonal is equal to a square root of 2 over 2 is equal to a over square root of 2. R is equal to half of diagonal is showing that the force is applied on the charge which is at the center. And then let's apply the Coulomb's law. F net is equal to 2kq q over a over square root of 2 whole square is equal to 4 kq over a square, which is the net force at the central charge. It is an evidence that whenever charges at the corners will not have same magnitude or same nature, then the net force at the central charge will not be equal to 0. It will have some value. Thank you very much for watching my video. Please like and subscribe my channel, which is a motivation for me to make some better videos for you. Bye bye.